This is team number 11, Band in the Box, final demonstration. Jeremiah Brooks, Jocelyn Caro, Brad Meadows, and Sean Kessler.
So introduction. Team Design Devils have designed 4 instruments that can play the ASU alma mater. The instruments designed include a recorder, pan flute, and glockenspiel, and a lyre. All of the instruments are capable of fitting in a 2x2x2 box. These designs are functional and meet the needs of Maroon and Gold 4. So the first instrument that we want to go over is the lyre. So here is my lyre. It's very simple. So the lyre can be tuned, each string individually. So each string can be tuned with these tuners. The design is cheap, as you can tell. Very simple design, so all the parts are replaceable. And it's simple to play. You just strum. And you just set whatever frequency you want for each string. So the string count, originally during this design process, there was a couple changes. I changed the string count from 8 to 3, simply because the length needed to be increased to hit the lower notes. The string length was increased from 6 inches all the way to 18 inches. That way you would be able to change the frequency. Bass structure changed from a tissue box to a shoebox. Tuners changed from paper clips to wood dowels, so pretty much the cake supports. String supports changed from rulers to these ukulele supports right here. And they changed the guitar strings to fishing line because they were easier to tune, and I could actually tune them. I couldn't tune guitar strings. Next slide. So lyre improvements, some improvements that could be made to this lyre. We're using guitar strings. Overall, the sound is much better. It's much louder. They're just extremely difficult to tune. I couldn't find an effective way to tune them individually. Change the length. If I was able to add more length overall to my structure, I may be able to hit those low notes a little bit easier. And adding frets. Adding frets would make the design much simpler to play, so you wouldn't have to change the frequency for each string.
The pan flute's the next design. The pan flute's a wind instrument made of 9 pipes with 1 closed end. The pipes are each cut to a different length to play each note in the high voice, and the parts can be found in any hardware store within the budget. Changes that I had to make. Originally, I was going to use a Sawzall to cut these, but proved to be inefficient, so I ended up using regular PVC cutters. The closed end, I ended up using pennies instead of styrofoam because the styrofoam took up too much space at the end of the pipe and it caused the frequency to change. And I had to add more pipes to meet all the note requirements for the high voice. There are no improvements that I would make because it's a fairly simple instrument to create with your PVC pipe. As long as your equations are correct and you cut it exactly to what your equations come out to, you will get the note that you want. So there's nothing I would change.
For the recorder is also a wind instrument like the pan flute. Design is very simple and can be easily replaced or changed per material. Parts that I used are easily obtainable from any hardware store, and it's simple to play. For design changes, I enlarged the holes to acquire a better frequency accuracy, and I changed the cedar wood stopper with an oak due to accessibility and improvements. Material change from PVC pipe to wood would be my preferable median. That's about all I got.
The glockenspiel is a percussion instrument. This glockenspiel is made of 7 1/8 inch thick and 3/4 inch wide aluminum bars. The aluminum bars are cut to different lengths to play each of the required notes of the ASU alma mater mid-high voice. Parts can be found in any hardware store. The changes I had to make during this process were due to the fact that I could not figure out what the speed of sound was from the internet. There were many different options. They range from 3,000 meters per second to 6,500 meters per second. So logically, I picked the speed of sound that occurred most often on the internet and within the middle of the range. Unfortunately, this was way off. I chose like 4,050 meters per second for my calculations, and it turns out the speed of sound in these particular aluminum bars is 5,100 meters per second after some testing. So that caused me to have to increase the length. I had to recut the aluminum bars to the correct length, much wider than originally thought, and I also had to widen the frame to accommodate the wider aluminum bars. Here are the links to all of our instrument demos. And here's our design budget. As you can see, all 4 of the instruments were below the maximum $15 budget.
Conclusion, the instruments provided were made with the most cost-efficient materials and meet all the size requirements set for the band. Each instrument is simple to use and will play the notes necessary to play Maroon and Gold 4's hit song, ASU Alma Mater. We worked very hard on these instruments and we hope you want to buy them. And these are our references.